So again, oxygen is in excess. This is limiting. And as such, I can now use the limiting, compare the limiting. So from the equation, my goal is to find the volume of gas remaining. These are all in gaseous state except for what? This water, because it's at room temperature and pressure. So from the equation, I need to find out how much of carbon dioxide will be produced. So compare the limiting, which is propane, and your carbon dioxide, 1:3. I already know this is actually 0.00. Okay. Yeah, 5. Okay. Oh yeah. This will be 0.015 moles. And with 0.015 moles, next one, we can actually find the volume of carbon dioxide times 24. Don't just copy blindly, girls. You all should be attempting. Got 0.36. So we can say volume of gas remaining. Total gas 700 plus minus 120 minus again. Okay. I need to find out what's the volume of carbon oxygen that we have. You know what? Let's do this. Oxygen is 5. So we need to find out how much it react. 0.025. So again, volume of oxygen remaining. Minus 0.025 times 24. I got 600.4 cm cubed. Wait, why is it? This is in cm cube, so I need to find out in cm cube. I get 100 cm cube of oxygen gas remaining. Volume gases remaining should be inclusive of the excess oxygen and how much carbon dioxide is produced. Answer is this. Okay, the board is question 3. I want to walk around for your question 4 and 5. For those who are fast, I'll just write the answer only, not the working, on the board. Question 4, my bad. Question 4, I'll just write the answer on the board for question 4. Again, any questions that I never get to go through, you can go back and try. Want answers, feel free to text me, yeah? Is it? Is it now, Myla? That's why
No,
miraculously or coincidentally unwell.
No, I was joking. She never tell us. It's just that we heard from the past few lessons.
Oh, is it?
She never say she's not coming.
Yeah, she say she will try to come.
Try.
No, I thought she was coming.
F for effort then.
Yeah.
Okay,
She said she
I'll walk around quickly. For those who are fast, you can go and try the other questions, but I just want to mark your question 4 because I want to see your
I
working.
got NA for OH is limiting. Then I got part B answer. But I used NA
Oh, sorry. Very wrongly. In excess. Yeah, you know what? Once you're done, let me mark. Because I still need to do periodic table. Again, excess and limiting. Roseanne, how do I identify dear? When the question gives you information of,
The two reactors.
and you can use the information to.
Find the most.
Yes, so that's why even if they never ask you to see whether it's excess or limiting, you must be able to decipher yourself. I want to showcase is very standardized in the questions they test for moles. Next time for O level, you must show me whether this is more or less than what we actually have. So this is what we actually have, right? So you must say that this is more than 0.05. That's why we have not enough. That's why NaOH is limiting. Okay? Reminder, there's no class next week. Don't come. What's your math is wrong? Can I ask? You have your oxalic acid. Why do you get O? The oxalic acid moles. This is why you use Na when I say oxalic acid. Oxalic acid is C2H2O4. Why you use the Na? That's why. Careless. Give me a moment. Let me mark the rest. Sure. Acceptable. Who else is done?
Yes. It was 1 million.
What is 10 to the power 6?
Please, don't always ask her. Sometimes she's just trolling you.
That's why I never believe her.
Okay? Believe in yourself instead. Believe in your ability to succeed.
The app inside the Google Codes.
Yes, correct. So please don't lose mark for moles. Very, very standardized. Always follow the step, right? Balance equation, find number of moles, compare mole ratio. If let's say you are stuck, please at least find moles or something so you can get at least some method marks. ask me? Asa?
No way, I can't figure it out.
Okay, believe in your ability to succeed.
No, you divide wrong side. It's not on top.
Why?
Because there's a bigger number.
No.
Are you sure?
Really?
This is 0.00, this is 0.0. This is bigger.
Actually, I don't know what I'm talking about. You got 0 got matter.
Yeah,
Still 0
that's
what?
Lisha, you done? Can I mark? Then ask you don't silent okay? But cannot, my hand too short. Okay, which part not sure? Do you see they already gave you the number of moles of oxalic acid? Right? Do you know what is the MR of oxalic acid? Sorry? You can calculate, right? Because you know what's the formula C2H4O4. Wait, C2H2O4, right? So, can I find the mass of oxalic acid? You can what? Because you have the moles and you have the MR, huh? Of what? No, that's not. They are asking that you cannot consume more than 0.05 grams. So we are just checking whether the mass that you consume, that means the 1.10 times 10 to the power minus 4 moles, is it going to be more or less than 0.05? You should be using that. You understand? Okay, so you need to find how much did he actually eat, okay, in that star fruit, because a single star fruit contains that number of moles. You can find the mass of oxalic acid in a single star fruit, and then later you can use that, see how many, what's the maximum number of servings you can form, which is the 0.05 divided by the mass of one serving. So what's your... Oh, you're not sure of B. Okay, you already know what is the limiting, right? Which is NaOH, right? So can we actually compare mole ratio to find what's the exact moles of Na2C2O4? Can, right? Because you know from the equation the mole ratio is 1:1 ma. Sorry, 2:1 ma. The limiting is NaOH, right? So if I know what's the number of moles of NaOH, will you know what's the number of moles of Na2C2O4? Yes, right? Agree? Then you can find the mass. Let's see. Huh? See me one serving. Hello. One serving. You have 0.0099 grams of oxalic acid. The goal now, if I do a bit of simple e-math with you, based on proportion, I want maximum of 0.05 grams of oxalic acid. Can you tell me how many servings you need? 0.05 divided by the one serving, right? Huh? 0.05 divided by your 0.0099. Okay, so you're not finding the number of moles. This one, they are saying this is the maximum number. So you are supposed to find, right now. Again, you are trying to find out how many servings I can have so that I can have reached 0.05 grams of oxalic acid. So if I were to do working for you, you already know the number of moles of one serving of oxalic acid. One serving, right, this number of moles, can I find what's the mass? Can, right, times my what? AR, right, sorry, MR, right, agree? MR, we can know what? 134, no, this, what's this value? 134, right? Is it? 134 is this one, I see only, I think. Oh, okay, but anyways, these are. Okay, so it's the MR, so it's 2 times 12 plus 2 plus 4 times 16, okay, grams. So once you find these grams, then can you find what's the number of servings? This one divided by your mass, okay? Can I mark? The rest of you can try the other questions first while waiting. I just want to mark question 4. You're working. Very good. Yes. Now you know why. Okay. Can I mark here? Thank you. Limiting. Okay, fine. I'm here, 3.35. Good. Working. That's fine. Number of servings. Presentation. I'm very particular presentation. Good. Roseanne, can I see? Let me see your working. Good. Good. Wait, I already say already. Presentation. Number of servings. I don't want to see this kind of primary school way of presentation. Hey, number of servings got 5.05 servings. How are you going to give me a 0.5 servings? 0.05 because it's 5.05 leh.
Take 1 bite.
Take 1 bite. Your 1 bite is like nibble. So please 5 I want nearest number, not 3SF. Understand? Okay, whenever you're ready, take out your this periodic table. Claire, I want to mark first. I urge you to go and practice the rest, but I told you already, there are 4 typical kinds of mole questions that you can predict. Okay? Excess and limiting is one of them. Yes, good. Yes, good. Good. 5 servings, then you always write nearest whole number. Okay? Okay, now can y'all take out your this periodic table? I already given out your this notes as well. If you have them, please take them out. Today in periodic table, I want to focus on is your group 1 and group 17. Things I want to focus is the unique properties of group 1 as well as your this group 17. I want you to focus on your 3rd and 4th column of the notes. Some of them is the explanation that's not in your notes, deliberately left out, so you can actually write them in your notes. Now, let's start off with your this group 1. One thing you need to take note, the name for group 1 is all called alkali metals. Idea from what we went through other metals, when they dissolve in water, what do they form? Alkaline. Think about sodium, you form sodium hydroxide, potassium form potassium hydroxide. But let's do a quick one since we did this. When group 1 metals dissolve in water, can you tell me, Roseanne, went through this last week. When the alkaline metals dissolve in water, what are my products produced? I went through this last week.
Wait. Oh.
Yes, I'm waiting. Help me, Alicia. Metal what? Oxide or hydroxide?
Oh, hydroxide.
Yes, and?
Hydrogen.
Yes. The metal hydroxide and hydrogen gas. Understand? That's why, right? The metal hydroxide isn't that like alkaline for alkaline metals. Anyway, one thing I want you to take note for group 1 is their unique properties that makes them group 1 metals. Do you see in your this 3rd and 4th column and notes is already in? Okay? You just start for me. First property I want you to take note is that they are soft. You don't just write soft. What must you elaborate, Claire? You must say soft and what? Can be? Yes, can be cut with a knife. I repeat class, you need to actually write both of them in exam. I want quality answer. Second one, group 1 metals, please take note, they have low density. However, when I say low density means less than water. What is actually the density of water, Zijian? 1 gram per cm cube. Which means that every single group 1 metal is less than 1 gram. For example, your sodium is 0.98 grams. So they all float on water. Understand? Last one. Your group 1 metals are, notice how I write the word relatively. They have relatively low melting point. Why am I writing the word relatively? Because if I want to compare with other simple covalent molecules, group 1 metals still have higher melting point. They exist as a solid. But if I want to compare it with other metals in your periodic table, your group 1 metals have relatively lower melting point. So you have to write the word relatively. Understand? In exam. If not, you'll be penalized. Now, this is the first one I want to point out. Second one is the trends. And you must know how to account for every trends that we have here. Let's start up with the first one. Trend number 1. As you go down the group 1 metals, what do you see there? Zitian, in gray. The trends are all in gray. First one, what do you see there? Oh, here. The trends in gray. You know what's gray? Yes. So down the group. So again, please take note, down the group, the metals will become softer and softer. It's easier to cut, okay, the metal. Like for example, right, your potassium, right, if I actually cut your potassium metal, they have the consistency of cream cheese. That's how soft they are. Now, this one, no need to take note. You just need to know the trend is softer. Density, what happens to density? Can you tell me? Jasmine.
Increase.
Density will increase or decrease?
Increase.
Okay, what is the explanation you will write in exam?
Me?
Yeah.
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 The AR increases. And
So?
unit volume increases.
So standard reasoning, AR, as you go down the group, it actually increases. So you always write the keyword, the mass per unit volume. Oh, sorry, I better write, increases. Please know the explanation. If it's not there in your notes, make sure you write at the side. Next one. Can you tell me, Chevelle, what's the next trend that we have here? Melting. Oi. I know what MP is. I want to know the trend there. So,
Decrease.
yes. Ready? Satu, dua. First one. Oi, my eyes here. Oi. Hello, my eyes not down there. My eyes here. So, can you tell me, Chevelle? First one. Why melting and boiling point decrease? So that the rest of them will just receive the notes. They know what to write for exam.
Ions.
You want word again, huh? Can you tell me right now?
Down
First of
the
all,
group. Down the group.
continue. I'm listening.
Ionic size increases.
Okay, so again, I'm listening. Continue.
Distance between positive charged nucleus and density of delocalized electrons increases.
Okay, wait. Your turn, Roseanne.
Electrostatic
Continue.
forces of attraction become weaker.
So,
Less energy is needed to overcome the weaker forces.
yes. FOA stands for force of attraction. Becomes weaker. So now we know lesser energy needed to overcome the weaker electrostatic forces of attraction. Already, eventually we'll do one round. One thing I want to point out, I want to mention about the terminology. Make sure you underline this. I'm not talking about atomic size. I'm talking about ionic size. I'm not talking about your valence electron. I'm talking about the C of delocalized electron. Again, this electrostatic force of attraction becomes weaker, so lesser energy needed to overcome. If you remember this chemical bonding, I say melting and boiling point is all about overcoming your forces of attraction. Whether is it covalent bonds or electrostatic force of attraction and ionic or this metallic bonds. Why? Think about, let's say we have this potassium metal. We know the way we draw, right, is always the cation. So let's try. Alicia went through this under chemical bonding. Describe the bonding arrangement of potassium metal. The cation. Metal cations are arranged in an orderly manner. Surrounded by what? What is this one in purple that I'm trying to draw? Held by what bonds? Can you tell me? Oi. Either you tell me metallic bonds or forming what kind of structure? A diamond 你的头啊 giant metallic structure. Do you see? Always tell me what are the particles held by what bonds, forming what structure. Again, with more fluency and charisma. So it's what? How do you describe bonding and arrangement in potassium? Metal. Arranged in an surrounded. Held by. What's this one you read? Strong or weak? Strong. Forming a giant structure. Now let's see. Do you see I never talk about atomic? Because the way you draw is always about the cationic size. Let's see. As you go down the group, let's start out with lithium. Lithium is again, you lose that one valence electron, you lose the entire shell. Your sodium, again, you lose that one valence electron, you lose that next outer electron shell. This is the ion for sodium. But next one, we see the potassium. Do you see the potassium has another additional electron shell? Number of electron shell as you go down this group, doesn't that increase? If the number of electron shells increase, will the size increase? Yes. So my question is, this is your electrostatic force of attraction, right? The positive charge ultimately comes from where? The nucleus, because that's where your protons are. So do you agree the nucleus is here? Distance between your nucleus and the sea of delocalized electrons. This is the nucleus. Isn't it going to be further and further? That's why the distance increases. Don't write valence, is delocalized electrons. So will the electrostatic force of attraction become weaker if it's further away? Yes. Will it actually have lesser energy needed to overcome this force of attraction? Yes. Understand? So know the explanation why. Does this also apply for barium or group 2? Do you think your group 2 down the group, your this melting and boiling point decrease as well or increase? Yeah? It also applies for group 2. So I repeat, sometimes they test for group 1, it also applies for group 2. Ziken, now you tell me, because group 2 isn't that just write a 2+, that's all. Okay, down your group 2, you have your periodic table in front of you, right? What happens to your this ionic size?
Increase
Yeah, then what do you say? Distance?
between the positively charged nucleus
And the?
sea of delocalized electrons increase.
So what happens to the electrostatic force of attraction? Becomes? Don't write decrease, weaker, and therefore lesser.
Energy needed to overcome.
Yeah, the weaker force of attraction. Understand? Okay, next one. What's the next trend? Oi! Next column already. Reactivity increases. Now I want to bring your attention. Reactivity, right? The reasoning is similar but not the same. So, again, it's already in your notes. Do you see on your this fourth column notes, okay, in the table? The explanation wise for your reactivity is, this time, I want you to highlight for me, you are not comparing ionic size anymore. You are comparing atomic size. I'm lazy to draw, but I will just draw here. Your lithium is actually 2.1, right, for atomic size. Sodium is again 2.8.1. Potassium is 2.8.8.1. So, do you see how the number of electron shells actually increase? as you go down the group. But when you talk about reactivity, am I talking about delocalized electrons, Chevelle? Talking about what? Yes, because you're trying to lose this valence electron. So let's try. Roseanne, tell me, as you go down, what's the standard answer to explain why reactivity increase? So later I can go through one round.
Atomic size increase.
So distance between
The valence electron.
and the
nucleus.
highlight the keyword class valence. Because one is delocalized, one is valence. They have different meaning. Continue.
Becomes further.
And then?
The electrostatic forces of attraction
Becomes?
weaker.
This time do we talk about energy? No. So what? It is more difficult or easier to lose?
Easier.
Easier to
Lose
The?
valence electron.
Yes. Understand? Clear? So does it make sense? So if I were to draw out, if I really need to draw out, it will be something like this. Your lithium will look like this. Your this sodium have an additional electron shell. Your potassium is even further away. So, to lose your this valence electron, do you agree between your valence electron shell and your this positively charged nucleus, as you go down, what happens to the distance? It becomes further and further away, right? What happens to the electrostatic force of attraction trying to pull the valence electron to itself? Also becoming weaker, right? Is it easier to lose? It's easier to lose this valence electron compared to your lithium. Understand? Clear? So remember terminology, make sure you highlight atomic size and then make sure you highlight valence electron. Highlight the word easier to lose. This is the standard answer. Ready? Let's go through one round. Starting with you, Zitian. Tell me, what's the first, again, unique property of your this group 1? 1, 2, 3. First one.
The metal becomes softer.
Metal becomes softer. Do you stop there? In its
Easier to cut when
very good. Second property that makes one group 1 metal unique. Density increases means they all on. Okay. Wait, what density increases? I'm asking about properties that is unique. Unique to group 1. They have low density. And they float. Yes. Why you talk about density increases? I'm not asking trends, dear. Continue. What is another unique property of group 1 metals? They have keyword. Right, melting not boiling Okay, so next one, Satu. Can you tell me what's the first trend for your this group 1 metals?
melting, boiling point decrease.
Melting and boiling point decrease. Explain. Satu, dua. First one,
Ionic size increase.
then distance.
Distance between the delocalized
Electrons and.
electrons and the positively charged nucleus increase.
So how do you end off? Oi, Alicia. So what must you say? The E
Electrostatic
force of attraction becomes.
weaker.
So it is.
Easier.
This is about melting. So more energy or less energy? Is needed to what bonds?
Overcome the electrostatic.
Weaker electrostatic force of attraction. Name me another trend here.
Reactivity increases.
Okay, 1, 2. First one. Down the group.
Now the group.
The.
Atomic size increases.
So distance between
Distance between nucleus
And
and
the?
valence electron
will.
increase.
Next one. How do you end off with? The
Electrostatic forces of attraction
becomes.
weaker.
So it's.
Less energy is needed to overcome the weaker electrostatic.
What are you talking about? This is not about melting and boiling point. This is about reactivity. Easier to.
Lose the valence electron.
Okay. Is it the same for group 2? Okay. So can you tell me for group 2, as you go down, does the reactivity increase or decrease? The reactivity will decrease.
Increase.
Increase. Explain. 1, 2. Down the group.
Now
Two.
the group. Atomic size increase. Distance between positively charged nucleus and valence electrons increase.
So how do you end off with? E.
Forces electricity.
Don't speak like Yoda. Continue. The
Electrostatic forces
becomes,
Nickel.
I must perform for you, huh? Easier to?
Oh, easier to use the
The-
balance.
Very good. Okay, next one. Another trend for group 1. Down group 1. We only mentioned 3. Last one. Slide D.
Wait, density.
Density will increase. What's the standard answer? Explain.
The molar mass increase.
So,
The mass per unit volume increase.
please write down. Okay, take note. Okay, now, however, what is the experiment to prove that rate of reaction or reactivity will actually increase? It's always this reaction here. On the next page, on the notes, first column, alright, the reaction to prove that reactivity always increase down group 1 is this. Alkaline metals can react with water to form your metal hydroxide and hydrogen gas. There will always be, you can write down in your notes at the bottom, 3 observations you will be looking out for to prove that reactivity actually increase. 3 observations are, number 1, again, this movement of metal. Will the metal move or not? Second one, will the hydrogen gas catches fire or not? If so, what is the color of the flame? Last observation is color change of indicator. You are expected in syllabus to know the color change in phenolphthalein metal orange universal indicator. So, again, that's why, right? Do you see we have in your notes? Lithium is going to be the most or least reactive group 1 metal. Can you tell me, Alicia? Is lithium going to be the most or least reactive group 1 metal? Least reactive group 1 metal. So that's why do you see? For your lithium metal, right? Again, you do not actually move. But instead, bubbles are formed around the floating metal. Why do I write floating? Can you tell me, Claire? Because lithium has
Lithium
oh, what's one property? They have
density.
yes, low density. Number 2, will the hydrogen gas catch fire or not, Zitian? So the hydrogen gas for lithium does not catch fire because it's the least reactive group 1 metal. Next one. If I were to have, let's say this color change of indicator, can you tell me if I add phenolphthalein?
Pink.
So, yes, correct. And then metal orange?
Orange. Green.
你的懂啊, hello, this is an alkaline metal. So this metal hydroxide essentially is alkaline. So again, what is the color change in metal orange? Yellow. If it's universal indicator,
Purple.
why not blue? Why not blue?
Because strong alkaline.
Strong alkaline. Definition of strong alkaline, standard answer. When you never write the T word?
Maybe I'm not done yet.
Oh, okay, can. I'm very patient. Come, line.
It is magnetically discharged. Oh, you know. Yeah.
Dissociates completely or partially.
Oh. Strong.
I give you 2 options. Why you give me option 3? Hello, dissociates what? Completely or partially? In to form high or low?
Concentration
Of?
H minus.
Okay, now, anyway. So, do you see if it's alkaline? That's why it must be purple. Question. Next one, do you agree that this sodium metal will react more vigorously? Will, right? So, will the metal move? Yes. This time, do you see the metal actually moves rapidly across the surface of water? Now, some schools use for hydrogen gas, they write hydrogen gas may catch fire. Some schools say that hydrogen gas catches fire and burns with an orange flame. Usually my advice, follow your school. Okay? So it's either one accepted for O levels. Next one, what's the color change or indicator if I add this universal indicator to the final solution? Roseanne? Oi,
Violet.
why? Because if I add sodium to water, what do I get? Products are?
Metal hydroxide.
Which is what?
Alkaline.
What is, we say sodium already. So is what? Sodium
Hydroxide.
Yeah lah, you say metal hydroxide. So sodium hydroxide, hydrogen gas, right? Sodium hydroxide is a strong or weak alkaline.
Strong.
So that's why it's purple in color. Understand? If it's methyl orange, what will be the color?
Yellow.
And then if it's phenolphthalein, what will be the color?
Pink.
Yes, very good. Okay, next one. How about potassium? Is it more vigorous? What's the way to describe for the movement of potassium metal? Reacts violently and again?
Dashes across the surface of
Yes, even faster than move rapidly, you write dashes across the surface of the water. Will the hydrogen gas catch fire? Burn with a what color flame? Lilac. So can you help me highlight in your notes? Lilac flame. Lilac is purple, so it burns with a lilac flame. And then next one, please take note, color change of indicator. It will also turn violet in universal indicator, yellow in methyl orange, and then pink in phenolphthalein. Now, my question is, Jasmine, if I ask, what will be the observation if I add rubidium to water?
explode.
I know, how you write for exam. I know, how do you write for exam? You don't write explode because I will explode for you. So it's what?
Reacts explosively.
Yes. So please take note. Hopefully you know, because reactivity increases down the group. The way you write, if it's for potassium, it reacts explosively. And then again, for your this rubidium, right? You say reacts explosively. Then how about cesium? How do you write that?
Even more explosive.
So you write reacts more explosively. Please use comparative words. Question. If I now ask you, don't avoid eye contact. Chauvel, can you tell me what will be the observation if I add barium to water? Describe.
It will explode.
Why?
Because it's like
Is it more reactive or less reactive than potassium?
less.
Less reactive than potassium, but again, it's also very reactive metal or not reactive metal? Very reactive metal. So again, in this very reactive metal, why? Because we already know down group 2, what happens to reactivity?
Increase.
Increase. And then calcium is also considered very reactive, alright? Agree? Remember last week I went through that? Alright? So sometimes they will ask you to predict. So you should be able to predict. Clear? So this is actually group 1. Next one, group 17. For group 17 metals, halogens. Okay, all these non-metals, I just want to point out few things you just need to take note for your this halogens is the trends. Let's start out with the trends for group 17 first. By the way, group 17 tends to form diatomic molecules. Again, for group 17, the trends are, first one, as you go down, please take note, your this color actually darkens. Now, you are expected in syllabus to know the color of all fluorine, bromine, iodine, and astatine in their standard state at RTP. Notice how I expect you to know what's the state symbol at RTP. Your bromine is the only one liquid at RTP. Let's see the color for this. You're expected in syllabus to know, so let's try. Starting with you, Roseanne, what's the color of fluorine?
Yellow.
Yellow. If you write pale yellow, also accepted. Chlorine, what color? Roseanne?
Greenish yellow.
So yes, or you can say yellowish green. Next one, what's the color of bromine, Alicia?
Reddish brown.
Reddish brown. Iodine is what color?
Black.
Black in solid state. However, I want you to write at the side for me. You are also expected in syllabus to know the color of iodine in aqueous as well as in gaseous state. Do you know what's the color of aqueous iodine?
Brown.
Brown. And then what's the color of gaseous iodine?
Brown.
No.
Yellow.
No. Is that P?
Pink.
Purple. Or you write violet, I also accept. However, can I ask, Zitian, how come I never write liquid iodine? How come I never write liquid iodine color?
Because iodine is solid and liquid state. And
Huh? What? Registering in your head? So why I never write liquid iodine? I only have aqueous iodine, gaseous iodine, solid iodine. Why I never write liquid iodine? Does iodine ever exist as a liquid? Yes or no only? No. Why? Can you now tell her? That's me. Yes. Okay, ready? 1, 2, 3. I want to see the 3 compounds in your syllabus to know that you actually.
Iodine.
No,
Yes. Number 2.
Not carbon dioxide.
Number 3.
Ammonium salt.
Like.
Ammonium chloride.
Very good. Ammonium chloride, ammonium sulfate. Okay, they all sublime. That's why you notice I never write this. But please know the color. Anyway, what do you think is the color of astatine, Alicia?
Very dark black.
Oh, really? Like who? My soul, is it? So it's what color? Can you tell me, Alicia?
Black.
You write blacker than black, huh? It's just black. Okay, there's nothing blacker than black, huh? So please take note, that's why color actually darkens. This is not in your notes, make sure you include your astatine in your notes, alright? Second trend, what do you see? The second trend, Claire? Density.
The density increases.
Okay, very good. Can you help me write? Okay, the reasoning why. Please note density, 2 reasons. Just need to tell me MR increase. How come I write MR not AR? Zitian? How come I never write AR? I write MR. No? Phone a friend. Don't want to be friends, huh? Oh, so Justin, can you tell me why did I not write AR? Why I write MR?
Because they got no AR. They only got MR.
Huh? How come I don't know, huh? No, hello, it's not, okay? Think about this. This chlorine, iodine, bromine all always exist as molecules, diatomic molecules. So that's why we always care about MR. So you have to be careful. Next trend. Chevelle, what's the next trend that you see there so the rest of them can actually write in their notes? The reasoning why.
Molecular size.
What are you talking about? These melting and boiling point will. Okay. I went through this under chemical bonding. I don't know whether you all recall. Give me my standard reasoning why your this melting and boiling point increase. That's why they have different physical state at RTP. First one, Chevelle. So the rest of them can write in their notes.
Because is a covalent bond. Our molecular size increases.
So molecular size increase. Continue.
Surface area. Surface area.
In the toilet. So it's what? Surface area
Increases.
to form.
Stronger. Intermolecular forces of attraction.
So which require
Larger energy.
to
Overcome.
yes. You all see this is a standard thing to explain the stronger intermolecular force attraction. I never say intermolecular force attraction are strong. I just say they're stronger. Okay, clear? Standard answer. Alright. Next one. Azan.
Reactivity decrease.
Just now, the reactivity, we're always referring to what kind of electrons? What kind of electrons are we always referring to for reactivity? Oi! Savi!
Valence.
Yes, I need to point out, reactivity is all about valence electrons. So, again, I don't care about molecular size. Highlight for me, we are carrying off this atomic size. If I want to draw the atomic size of fluorine, you should know is 2.7. This chlorine is 2.8.7. And then your bromine is 2.8.8.7. Okay, question. Roseanne, am I trying to lose or gain electrons here for the halogens? Lose or gain?
Again.
You're trying to gain electrons. So let's try out. The reasoning is very similar from your this group 1 reactivity. So let's try. Down the group. Can you now tell me, Alicia, what happens to atomic size? Increase. So what do you say? Always the distance between positively and the C valence. Continue. Electrons will increase. Then how do you end up with, Claire? The what kind? You know why still electrostatic? Positively charged nucleus, valence electrons. So I tired already. So I got 你的头啦 electrostatic. The electrostatic force attractions becomes weaker. So it's difficult, more difficult or easier to gain? You think about this, further and further away, the magnet.
Easier to gain.
Huh? But your magnet further and further away leh. So so no. Then it's what? More
Difficult
to
gain
and E.
electron.
Yes. Okay. Get ready? 1, 2, 3, 4. Explain to me why reactivity decreases down the group of group 70. Down the group.
The atomic size increases.
Very good. Next one.
The distance between the positively charged
Nucleus and the valence.
valence electrons increases.
Next. Oi,
No.
Are you okay? Breathe, dear, breathe. So it's what? The E
Forces, electrostatic forces
becomes.
stronger.
She's not processing. Hey, you further away. So it becomes. Next one, how do you end off with? Roseanne?
It becomes more difficult to gain the electron.
Okay, can we go through one round for both your this group 1 and group 17 trends? Ready? Tell me one trend for group 17.
Melting point, boiling point,
Increase. Explain. Down the group. The what size?
The group, the atomic
Semi-atomic, they exist as molecules there. Down the group, the what size? More.
molecule size increases.
So the what increase? So
surface area
in to form
to form stronger electrostatic.
no, not electrostatic. If you do not understand why, I will draw a sketch for you all. This is, let's say, your fluorine molecule. Do you know where your covalent bonds? This is your covalent bonds, right? And then they will form what? Your this. Yeah, so again, do you see this is the molecules? Okay? Then between the molecules, you will actually form your intermolecular force attraction. So imagine, right? If your molecular size, your molecular size is actually larger, wouldn't the intermolecular force attraction become stronger because you can form more of them? Understand? So again, down the group, the molecular
size increases.
So the
surface area
increase
increase
to form,
stronger intermolecular forces of attraction,
which require.
require
More
energy to
to-
overcome.
Very good. Name me another track for group 17.
The density
In
increases.
okay, explain.
The
Yes. MR.
the MR increases.
So mass.
Size of particle.
No. Think about this. What's the units for density class? Density units is grams per cm cube, right? So the mass per.
Unit for
Will?
increases.
Yes. Okay. Next one. Another trend. Reactivity. 1, 2.
Decrease.
I know. Explain.
Atomic size.
Yes, my perform for you. Atomic size increase. So
Distance between positively
charge and
valence electrons
will.
increase.
Okay. Then. Oi. 快点. So it's what?
Electrostatic forces of attraction.
Becomes. So hence.
Easier.
easier? I wonder where this will lead to. This is group 17, 7 valence electrons, more 2, the 7,
1.
We are at group 17.
To gain 1.
So, again, and off, more
More.
difficult. 2.
Gain 1 electron.
Yes, okay. Next one. Can you tell me the next one about your this group 1? What is one trend for group 1? Oh,
The metals become softer.
metals become softer. Okay, as you go down to group 1. Again, what is another trend that we can say for group 1? Melting. Well, okay, start to do what? First one. How do you explain melting and boiling point decrease? Down the group. The size or ionic size. Which one? That you want to draw, do you draw as atoms or do you draw like your this cat ions arranged in an orderly manner? So it's what size? Ionic. Quite very tired. Ionic size. Oh, must perform for you, huh? Okay, come. Ionic size. So the distance between the positively charged nucleus and what kind of electrons are we focused on for ionic bonding? Metallic bonding. And the C of will increase. So then how do you end up with the
electrostatic forces of attraction
becomes
stronger.
semi strong? Yes, of course, not stronger, so weaker. So it's lesser or more energy?
Less energy to overcome
The weaker or stronger?
electrostatic forces of attraction.
Very good. Next one. Name me another trend for group 1. Yes, swallow. So it's what?
有什么还没有讲的
Say until I hear something that I haven't 讲 yet.
？Low density.
Low I'm talking about trends, dear. Trend down group 1. What else?
Density decrease.
Yes. Oh, okay. So wait, did you say decrease? The AR increase. So density
Increase.
increase. So what's the explanation?
The AI increases.
So?
The mass per unit volume increases.
Okay, last trend.
Melting.
讲了.
Our reactivity
Well,
increase.
okay, start to do
But
first one.
just now I say already.
You say for the group 17.
Same.
Same ah. Oh, since they say same, then you think all. Okay, Roseanne, explain now. Why reactivity actually increase down group 1?
Atomic size increase. The distance between valence electrons.
And?
Valence electrons and the nucleus.
Not 7. This is group 1.
Oh wait.
Between valence electron and the?
The nucleus increase.
So the
Electrostatic forces of attraction become weaker.
hence it is.
Easier to lose 1 electron.
What is the reaction to prove that the reactivity increases down group 1? React with what?
React with water.
And then what will I produce if I have group 1 metals react with water? What are the products? Metal. And
Hydrogen.
what's the test of hydrogen gas, Chevelle? What's the test of hydrogen gas? It will I will explode you. Hello, extinct. Oh, okay, can. Very good. Next one. Can you now tell me what's the reaction to prove that group 17 reactivity decreases down group 17? This place. Man. Class, do you see on this page of your notes? Second page of your notes. Anyway, on the second column, you all see displacement. If it's actually 1 mark, they ask you what is displacement. This is always what you write. If it's 1 mark, you always tell me the more reactive halogen can displace the less reactive halogen from its salt. So I repeat, the more reactive halogen can displace the less reactive halogen from its salt. If it's actually 2 marks, what do you actually write? Again, you have to elaborate with effort. Can you help me highlight? Because the more reactive halogen can gain electron more readily. Okay? Can you help me cancel from the less reactive halide to form halides? I repeat, the more the answer, if it's 2 marks, the elaboration should be the more reactive halogen can gain electrons more readily to form anions. Understand? Okay, so now let's try. Whenever we deal with your displacement, we always have to deal with coming out with your chemical reaction ionic equation as well as your this observation. Can you now tell me, can this actually occur? Etienne? Can your chlorine displace bromine from its salt? Can or cannot? Can. So what will the products be if displacement does occur? Displacement is just kick them out and replace them. So you form? Okay.
Chloride.
Yes. And bromine aqueous. This is now a balance equation, right? But let's ask you, Jasmine, tell me, if I want to write down the ionic equation for this, what will be the ionic equation for this displacement reaction?
K plus
Question.
Cl minus.
Will we ever care about potassium here?
No.
Why?
Because most I forgot.
No, it's not because of that. If there's no change in your this oxidation state, do you see potassium? There's no change at all. So you will never ever include into your ionic equation. Understand? But the rest there's oxidation state changes. Alright? So try.
Cl minus Cl2 plus Br plus
This is it an ionic compound or is it a molecule? Ionic compound or molecule here?
molecule.
Metal and non-metal is what? Ionic. So is it an ion?
Oh minus
So Br minus will give you what?
Cl minus
And
Br.
is this balance? Then balance for me. To where?
There.
Then where?
Br2
Oh.
Br minus
Br minus, what else?
Cl minus.
Okay. This is not in your notes for those who just receive. For this, make sure you know how to write. Chevelle, tell me the observation. What's the color of this if I add this to here? Originally, this what color? Potassium bromide. Colorless. And then later I'll start to form bromine, right? So what is the color of this? Because this is colorless.
Red brown.
Reddish. Okay. Now, how are you going to explain in exam, Chevelle, for observation wise? What do you write? The
Colorless solution.
potassium bromide will turn. Oi!
Is it not solid?
Semi-solid. Hello, what do we already learn about bromine? But again, because it's mixed with water, so it's aqueous, right? So color.
Reddish.
Again, observation.
Potassium.
Color, yes, will turn
Colorless to reddish brown.
from colorless to reddish brown. Understand? Okay, so if I were to have iodine, let's ask iodine cannot displace any substance, but your chlorine can displace iodine from its salt. This is AQ, and then you will form your here, right? Explain 1 mark, Roseanne, how come this can occur? By the way, what state is this, Alicia?
Solid.
Correct. Okay, come on, quit it.
Chlorine is more reactive than iodine
And
and can displace iodine
from its
potassium.
salt, right? If it's 2 marks, then what you do? Further elaborate by saying
Chlorine can gain electrons more easily to
Form.
anions.
very good. Okay, you, Alicia, tell me what will be the ionic equation for this?
Cl2
Plus
I
I, is this an ionic compound? Yes, right. So I what? Got charge. Hey, metal and non-metal. Ionic, right? So got charge or not? What's the charge? Why is group 17? For the love of God, this is 17. So it's okay. Oh, what will I form? Cl. Is this an ion? Is it in an ionic compound? Yes, right. So Cl and I. Okay, is this balanced? No, right? So what do I write here? And then what do I write here? Okay, now question, observation. This is what color?
Black.
My heart will turn black. Hello, this is a sparse salt, not a transition metal. So what is color is this? This colorless. Colorless potassium iodide will turn what color? Don't know. By the way, in exam, anything related to iodine, right? You always must write brown with black deposits. Why? Because at first the iodine form is aqueous iodine. But we learned at room temperature, iodine will solidify. So the brown is actually iodine, the black is also iodine. But you always must write this. So highlight in your notes, must always take note, if it's iodine, you must write brown with black deposits. Include your ionic equation in your notes, especially for those who just received them as well. Clear? Clear? So this is your ionic equation. Clear? So these are the things you just need to take note. The notes are quite self-explanatory. I forgot stapler, so you all take one and pass down. Okay, can you take one, pass down? Each one of you will do me the respective questions for me to mark. Zetian, Chevelle, and Alicia, I want you to do for me question 1. The rest of you, do you see we have question 4? I want you to help me complete question 4. So I repeat question 1 and 4 respectively. Once you're done, let me mark. okay? No.
I don't do anything wrong.
You never do anything wrong. Then you laugh for no reason. Then there's something wrong already.
Whatever she got initially.
Oh. Now I remember now. Oi, do your homework.
No, I think
Thinking by looking over at a distance, is it? Once you're done, let me mark. Wanna ask me? Oh, Shivan, let me just pass you the bio. Hey, I think there's an additional one. Can you give me? Thank you. Once you're done, let me mark. While waiting, you can try the other question, which is question 1 and 4. Thank you. Weaker, not becomes weaker. I'll give you a full 3 marks. Very good. Try the other question 1. Again, who is done? Let me mark. Know your standard answer. Never lose marks for this. Thank you. Very good. Okay, you can see our answers very standardized. Thank you. I will not accept very, because this is group 2. Think about how calcium you want to say explosively. You just write explosively. Okay? Please don't write that. That's only for group 1. Huh? See me at room temperature because they react very under oil lah. You store under oil. See me room temperature, please ah. Don't scare me ah. Yes, correct. Yeah, further away. Why do you talk about intermolecular forces attraction when it's talking about charges? Do you know when to use intermolecular, when to use electrostatic? Very simple. Electrostatic is always got charge on. Positively charged nucleus, negatively charged electrons. So because you use wrong terminology, cannot give you credit back. Easier to lose electrons. I only can give you 2 marks. Okay. Who else? Please try question 1. Then after that, I want to go through this. Then I'll be completed. This parts. Nope. Please take note, mass number doesn't always increase. Let me show you. Do you see in your periodic table we have this tellurium and iodine? Te. You decrease, so no. Okay. So you say that it's not true. Atomic radius always decrease across the period. So wrong. Melting point does not always increase. Only true down the group? No. Let me explain. Down group 1, what happens to melting point? Decrease, right? Isn't it down the group, but you say only true down the group, No. Okay? Character, this is the only one correct, so 0. Ki turns from, yes, I accept. Down the group, make size increase. So that's why smaller than this, distance between positive and this is smaller. Why you talk about melting boiling point? Why you say less energy required to overcome weaker? They are talking about reactivity, not talking about melting boiling point. That one is to explain melting and boiling point, right? So don't want to take that. Less energy to gain. That's why it's more reactive and able to displace. If I tell you, as an examiner, sometimes if I see something at radiance already, I cannot give the full credit even though you have all the points. Okay? Who else is done? Let me mark. Thank you. Mass number doesn't always increase. Let me explain. Do you see your periodic table? I have periodic table with you. Do you see Te and iodine in group 16, 17? You see mass number decrease? So not always true, Okay? Atomic radius decrease. You say not always true for both. No. Atomic radius always decrease across the period. Will always. Okay? Next one, melting point increases. Again, yes, it's true. Character, yes, it's true. I'll give you 1 mark here. Color solution turns brown with black deposits. Very good. I'll give you 1 mark. So, chlorine gas able to displace iodine from this. So chlorine is less reactive. So again, you see atomic size increase, valence electrons further away from nucleus. Reactivity decrease down the group. I will give you your full 3 marks here. Okay? Who else? Chevelle? Done? How many marks? No, mass number doesn't always increase there. Do you see your periodic table? Do you see group 16, 17, T, E, and I? Do you see the mass number actually decrease? Can I ask you, you say atomic radius decrease down the group. You still not. Down the group got more electron shells or fewer electron shells? Yeah, why you say decrease? Yeah, but you write decrease. So, wrong. We will not accept. Melting point increase. Down the group, no. Let me explain. Do you agree down group 1, what happens to melting point? Yes. So is it true? Down the group? No. Only can give you 0. Colorless potassium iodide, turn brown with black deposits. Yes. Down the group, atomic size increase. Further away, electrostatic becomes weaker. More difficult to gain. Chlorine is more reactive. Displace iodine from this. I'll give you the full 3 marks. Roseanne, have I marked yours?
Yeah.
Okay, come. Can we quickly go through? Then we can go back and hibernate. Any questions that I'm never going to go through? Answer sheet is already behind. So all this is a practice. I want to talk to you all about 1A. Okay, 1A is for you to understand. Mass number doesn't always increase, okay, across the period. Let me explain. If you were to look in your periodic table, do you see group 16, 17? We have tellurium and this iodine. You see mass number decrease from tellurium to iodine. So not necessarily your mass number will always increase, okay? The only one that is always true is down the group. So answer should be down the group. Atomic radius, does it decrease down the group or across the period or both or not both, Roseanne? Atomic radius. Sorry, does it decrease down the group, across the group period or both or not true for both? Across the period only, correct. Melting point increases. Can you tell me, Chevelle? Down the group, across the period, true for both or not true for both? Not true for both. Understand? Next one, character, you all should know already, only true across the period. Okay? So this is 2 trends that you realize across the period. Number 1, always remember, atomic size decreases across the period. Metallic character decreases across the period. This is the 2 trends. For those who just received the notes, you better write on the first column of your notes, first picture. Again, everybody can take note. Answer sheet behind is Arrhenius. I don't want to see colorless potassium iodide turns brown. I want to see brown with black deposits. So make sure you write and change this answer sheet behind. This is for question 1B part 1. Answer sheet behind is Arrhenius. Next one. Because they are just asking to compare between chlorine and iodine, please take note. The first mark is just telling me chlorine is more reactive and able to displace iodine from its salt. If you want to tell me increase or decrease, now I give you credit this time for those who I mark, telling me the trends. But please don't write trends in exam. If they already just ask you to compare between 2, you just tell me smaller, larger, further, weaker, things like that. Okay, so chlorine has a smaller atomic radius, and that's why distance between positively charged nucleus and the valence electron is smaller. So that's why, again, more difficult to, easier to gain an electron. Understand? As long as you tell me all the things that I made you memorize, okay, and just tell me it's more reactive and able to displace, I can give you the credit. Next one, for question 4. By the way, class, if they say react with water, if you write magnesium oxide, I will not accept. Please take note, whenever react with water, write magnesium metal hydroxide. Okay? Now, one more thing is, for group 2, we expect the reaction to be a vigorous reaction. but never write very explosive for group 2 metals. The very explosive is the only term for group 1 metals. Understand? So even though you're this, what is this? What is this metal? Radium, huh? Is it radium? Oh yes. So radium, right, again is in your group 2. So radium we already know is actually your group 2 metals. Please don't write very explosive. It's only accepted for group 1. So either you tell me explosive or violently. You write violently, I also give you credit already. Okay? Next one. Radium is group 1, right? So where do group 2, right? And it's very reactive. So where do I store? Under oil. You all should take note, under oil. Alright? If you write under inert environment, I will not accept. Okay, next one is standard answer. So again, this is about the one that I asked you to write to Chan in class just now. This is why I made your Chan in class twice. Understand? So again, just say it's more reactive when it's larger in size. So why? Distance is further away. So it's again weaker electrostatic force of attraction. Easier to lose the electrons. Understand? Standard answer. This is why everything that I just went through, that is actually a key standard answer you write for exam. Clear? And with that, I end off here today. There is no class next week, so don't need to come for class next week.